right, so at this point you should know how to simplify radicals and pull out perfect squares that are in them to simplify them. Now what we're going to do is we're going to multiply two radicals together and then simplify them. So if you look at this first example, I've got a square root of 3 that I'm multiplying by a square root of 5. Well, all you have to do, in the same way that we can separate a radical into two parts, we can merge it back together into one part. So in this case, when I take the square root of 3 times the square root of 15, I'm going to end up with the square root, I'm sorry, I said that wrong, square root of 3 times the square root of 5, I'm going to get the square root of 15. So you just multiply the two radicands, those are called the radicands, inside the radical. Now, after you do that, you always want to come back and you want to look at your list of perfect squares and decide if that is going to reduce. And the square root of 15 will not reduce, so I will leave it alone. Let's look at number 2, though. On this one, when I multiply the two radicands together, I'm going to have the square root of 20. Now the square root of 20 does reduce because 4 goes into it. So then I'll break it down to the square root of 4 times the square root of 5, which would reduce to 2 square root of 5. All right, why don't you try these next two on your own? Pause the video and then come back and see how you did. All right, so on this first one, when I multiplied my 5 and 15, I got a square root of 75, and then I broke it down into different factors. Rather than 5 and 15, I chose 25 and 3 because the square root of 5 comes out nice. So that one would be kind of like our number 2 up there. Number 4 was a little bit different. When I multiplied the radicands here, I ended up with a square root of 4. The square root of 4, well, notice that 4 is our perfect square list. So when I take the square root of 4, I just get 2. My answer doesn't even have a square root in it. That's actually an important concept that will come back to us when we start dividing. But anytime you multiply two radicals that are identical there, they're always going to get you a perfect square because you're taking something times itself. So when you get this perfect square, then it comes out as a nice whole number there and you don't have a radical on it anymore. It's kind of a handy feature or a handy method there to get rid of the radical. Keep that in mind for future. All right, let's try more. What happens if I stick a coefficient on my radical? Well, I just kind of treat it almost like I'm multiplying with a variable attached instead of a radical attached. I'm going to multiply the two parts that are out in front. So in this case, my two coefficients, a negative 5 times a negative 5. And since those are not underneath the radical, when I multiply them together, it's not underneath the radical. So I would just have a 25. But the two radicands can also be multiplied, but since they're underneath the radical, they stay underneath the radical. And then I look to reduce, and I'm trying to reduce the 6, not the 25. The 25 is already outside the radical, so don't be thinking, oh, look, 25. It's already outside the radical. No need to do anything with it. It's this 6 that I'd want to reduce, and since I don't have any perfect squares that go into 6, then I would be done right there, 25 square root of 6. All right, let's try number 10 here. I'm going to multiply the coefficients, and so multiplying the coefficients would get me a negative 6, and then I multiply the radicands, and I get a 16. All right, hopefully some bells are going off in your head. Look, 16, square root of 16. That's actually going to be beautiful. That's a perfect square right there. It's not a matter of breaking it down. It's simply going to come out as a nice perfect square. And so the square root of 16 is just plain old 4. Now, if that's not in the radical anymore, then I can go ahead and multiply it by the negative 6, and my final answer would be negative 24. So that's a perfect scenario if somehow or the other you can end up with a perfect square underneath your radical. Okay, let's try one more together. Number 11 here. I have a negative sitting in front of this radical. So think of that as a negative 1 sitting there. So it's a negative 4 times a negative 1, which would get me a positive 4. And then the square root would be the square root of 18. Look at your list of perfect squares. 9 goes into 18. So we break this down and we put our 4 first because it needs to stay there. We break down the square root of 18 into square root of 9 and square root of 2. So then that becomes 4 times 3 times the square root of 2. And then I can multiply the 4 and the 3 to get 12 square root of 2. And that's my answer. All right, so now I want you to pause the video and try number 12 here. So hopefully you got 20 square root of 6. If you did not get 20 square root of 6, look at my work. It's so important when you're working with radicals to show those steps each time. When we start doing shortcuts, I promise the shortcuts are where we start goofing up. A lot of people will call this right here 4 square root of 6. And they just forget that the 4 is still underneath the radical and they ignore it. And so be sure to write each step down so that you don't start making some silly errors. All right, I've got one last thing here for you, and it's distributing radicals. Because when we distribute, we take this number out in front of the parentheses and we multiply it through both of these. Well, notice I just said multiply. So distributing is really multiplication. You just have to do it twice. So I'll take the square root of 2 times 3. Well, I can't really multiply those together, so I'm just going to write them together, but I'd write my whole number in front of my radical. Then we distribute it to the next one. I have the square root of 2 times the square root of 2. So that would get me the square root of 4. Oh, remember we talked about that last time. When you take two radicands that are identical, you're always going to get a perfect square right here. So that's going to come out nice. I'll have a 3 square root of 2 plus 2. And we haven't talked yet about adding and subtracting, but you cannot add these two parts together because this one has a square root of 2 attached to it that needs to get multiplied by the 3 before the addition can happen. And I don't really have a nice clean way to do that. I'm done right there. All right, let's try one more of those, a little trickier. I've made this number out in front a little messier. So we're going to take this whole thing and distribute it. When I distribute here, the coefficient on this radical is assumed to be a 1, so I would be taking a negative 5 times a 1. Then I will take the square root of 10 times the square root of 3 and get a square root of 30. Next, I'll want to take this and distribute it to the second term. Again, I'll have a negative 5 out in front, and it's going to be a square root of 50. After you do the distributing, that's when you look to do any sort of simplifying. And when I look at 30 and I go through my list of perfect squares, none of those go into 30, so I can't really reduce the square root of 30. Let's look at our square root of 50. Right here, 25 will go into 50. Let's go ahead and reduce the second part. The first part will have to stay put. The second part will become a square root of 25. Sorry, that's kind of messy. Times the square root of 2. That leading part just keeps getting drugged down, doesn't change. This becomes a negative 5 times 5 times square root of 2. Remember that your goal was to get this part that was going to be a perfect square to come out nice. And once it is nice, you can multiply it times the other number. So again, negative 5 square root of 30 plus, well, I'll tell you what, can we go ahead? I know that this is going to end up a negative 25. Can we just call that a minus instead of a plus a negative? Now that is totally reduced. We really spend more time in the simplification process than we do in the multiplication. So it's just a tiny little added thing to what you've already been doing. All right, so go give your homework a shot. Good luck.